All right, hello everyone, and welcome to something that Ahmed came up with. Ahmed thought it'd be fun if I tried to live code a HackerRank challenge that I have never seen before. I hereby do solemnly swear I have never seen this challenge before. So,
Can confirm.
let's take a peek at it.
Did Ahmed pick out the challenge?
Correct. All right, given an array of integers, find the subset of non-adjacent elements with the maximum sum. Calculate the sum of that subset. So, given an array with these 5 elements, these are the possible subsets. So the maximum subset sum is 8. But they need to be non-adjacent elements. So, yeah, there's no -2 that has a 1 after it. The only ones that 1 has is -4 and 5. And it can't have -1, -4, and 5 because -4 and 5 are right next to each other. Okay. So complete the max subset sum function in the editor below. It should return an integer representing the maximum subset sum for the given array. Has the following parameters, an array of integers, and the input format, the first line contains an integer n. Oh, I see. What is the integer n? So the constraints are that it's between. Oh, I see. They're giving me, so this is answering questions about how big these numbers can get. That's fine. All right, and then they give me some samples. I can pick a language. Oh, Dagios. I see. They have it all filled out, though. I was like, I got to read it off of the command line with FS, but looks like they have that all ready to go, so it just needs to be that. All right, cool. So, all right, I think I can do this. Let's, first thing I'm going to do is I'm going to work on this problem in my own editor because I want to break this problem down a little bit. So I'll call this let's see, max array sum. Make an index.js. Let's make this a node project. Like, especially with this kind of stuff, I don't do shit without tests. So let's install jest. I'm actually not sure if I'm going to use it, but I'm going to throw Lodash in here anyway. Actually, no, I can't use Lodash because they probably won't let me use it in the solution. That's all right. So what I'm thinking is that the first thing that I want to be able to do is generate those subsets. Because after that, it's pretty easy. Actually, shoot, I can even just do the rest of the problem pretty quick, just so I have it. Touch test index spec.js. All right, cool. Should be good to go. And I'm going to resize pane. Cool. All right, so if I try running just watch all CPX, just watch all, there she blows. Cool, so I'm gonna make a test, make sure that this stuff is wired up okay. Expect one to be one. All right, I got my first passing test. Back over to the problem. So given this array, oh, it won't let me copy it. That's annoying. All right. So I'm going to, we'll call this like it finds the max non-adjacent sum of array elements. That's why I hate these challenges. Oh, you know, like I do. Let's say that the array is -2, 1, 3, -4, 5. And I expect that if I call max array sum with the array, I should get back 8. Okay, so that's how I'll know that I'm done. Perfect. Some other things, so looking down here, so I can also like put in some tests for this summing. Like that part's pretty easy, should be at least. So I'm going to make a function called sum. And then I'm going to make some tests, -2, 3, 5. And I want to look for like, even for something like sum, may as well make sure that I have some, I don't think I need to do all 7 of these, but I want some representative cases. So I want one with 3, I want one with 2, there's none with 1, there's none with 0 in there. Although it should work with those, so I'm going to use those as like my equivalence boundaries also. So if I do -2, 3, and 5, then I expect that summing the array should be, so it's 8, 6. Other things that I would expect out of a sum function, if it's empty, I would expect summing that to be 0. If there's only one thing, it should still be that. Cool. And otherwise it looks all right. So cool, all of those are failing. Yep, 4 total, 4 failed. Perfect. So I'm going to skip this one for right now. And I'm going to start by making sum. Takes in numbers, module dot exports sum. Cool. So I import it over on this side. Nope. Hey, what's up, motherfucker? Pretty good. Ahmed is, so I'm currently getting my ass kicked in front of the students right now. I think Ahmed's over in the lab, or somebody who looks a lot like him, and John is very loudly reviewing student things over there. Sounds about right. Beautiful, you're beautiful. You're beautiful. Cool. All right, so it's saying returns undefined. Well, so it does. So how about I just return numbers? Not undefined anymore. All right, so now I can do, so in XP, this is called obvious solution. I know exactly how this works. I'm just gonna reduce it. Take that, initialize that to 0. Sum number, and then we'll do sum plus number, and everything's passing. Cool. So purpose of that is whenever I do figure out what these sets are, then I should be able to feed them into that sum thing and get their sums. Now, if I'm working backwards, though, there's a couple other parts to this now that I'm realizing it. So we also need one that like takes these like collections of sets we have and gets all of their sums. And we also need one that's going to like just find the highest number. So we'll do the next easiest one. It's gonna be max. So it's just going to give me the highest number in an array. So I'll say 1, 3, and actually, a few different ways I could do this. I was just thinking like, I'll do the easy one first. If it's 1, it should just be 1. So I expect that an array with 1 in it, max array, to be 1. All right, I got a failing test. This is something where like Lodash would certainly come in handy. Okay, so what I was thinking, I can make this pass real fast, was that I could, all right, cool. So I could, like the next one that I want to do is like 2 of them. And then I was like, oh, well, I'm not guaranteeing the order of these. So maybe I do something like pass in a 5 and a 1 so that it needs to be the first one. But that's just sorting. And so that made me think, well, if I sort the list first, that certainly makes that a lot easier. So that's I think that's actually how I'm going to solve this. So but first I'm going to do 1 and 3. So I expect that one to be 3. Cool. And so now I have something that I can't like solve by being cheeky. I can do that, but now the other one's going to fail. I think the way that I want to do this is just sort whatever array that I get, and then take the last element. Like they have to be numbers, but assuming I'm getting valid input, then that'll work, man. So really, this is numbers.sort, and then you take the result of numbers.length -1. Does that make them both pass? Hey, it makes them both pass. Cool. So that'll do that. All right, so if I give it an array of numbers, and just to sanity check myself, and do one more in just kind of a weird order. Hey, and it still passes. Strictly speaking, I never saw it fail. That's kind of an important thing. Awesome, that works. Okay, so if I am given an array of numbers, I can find their maximum. If I'm given an array of numbers, I can find their sum. So the other thing that I need is I need to be able to take an array of arrays and turn them into an array of sums. So that's going to be something like describe sum arrays. So this will be something like, I'll start with an easy one. 3 ones. So the array is and I expect that if I call some arrays on arrays to equal 1, 1, 1. Cool, something like that. All right, some arrays isn't defined. Cool. Cool, very nice. So this is another like obvious solution. I'm going through each of them and mapping them with sum. Cool, that does it. So I'll come up with a couple other examples. So do different sizes. Let's see, I'll even do an empty one. So I would expect that to be 3, 19, and 0. Oops, that's what the result should be. 3, 19, 0. These ones should be 1, 2, 1, 5, 13, and an empty array. You're beautiful! Same thing, I want to make sure that it doesn't mysteriously pass. Cool, works. Awesome. So now I'm at the hard part of this problem. Hard part of the problem is like finding these subsets, but once I've figured out how to do that, the rest of the problem is solved. That's a good place to be in. Like, because even if you were starting with finding those subsets, like the weight of the rest of the problem can still kind of sit on you a little bit. And now we just have a much simpler thing in front of us. So if I called this get non-adjacent subsets, I can also write some tests for this that are that like weren't in the original puzzle, which I think helps a little bit, including just some easier ones to help me figure out what the logic on this should look like. Okay, so the only possible values from that are 1 and 5. So if I say that, then result should be that. So I expect that get non-adjacent subsets on array to equal result, and it does not. Cool. So get non-adjacent subsets function get non-adjacent subsets. All right, cool. So now we're down to the problem. So think about how I might make this pass. My first thought is, okay, so like indexes matter on this. So like I can't reach for any of like my easy applicatives. Ooh, actually, I might be able to like hack filter a little bit. All right, I'm just gonna make some kind of stream of conscious notes. Use filter with index. So this would be like the first argument to filter is like whatever item is current in there. You also get an index as the second argument. And so we could do something like use flags for adjacent element. Oh, I've got a great idea for this now. Cool. So I think what I want to do is have some like a flag called is adjacent and set it to false. Then what I'm going to do is filter this, and in the filter I'm going to take the number and the index. And so like actually I just thought of a scenario where this isn't going to work. All right, I'm going to get to that next. If I do something like number, let's see, if is adjacent, if is adjacent is false, then return true and flip it so that it's true, and then just do the opposite otherwise. So if adjacent is true, then we make that false and we skip it. So that, okay, so that'll give me every other one, but it won't get me the sets that start with like by just skipping the first one. This would have the first one in every single one. All right, so that was like my first test. Yeah, okay. So these are all the examples. Let's just take those. So if I take in -2, 1, 3, -4, and 5. Then call this given subsets. I'm just going to throw all of them in there. So I would expect get non-adjacent subsets of array to equal and I'm noticing, yeah, so I did this one wrong too, because this would really be that. I want like an array of arrays on that. So the first one isn't right either. So this one should equal -2, 3, 5. -2, 3, -2, -4, -2, and 5. 1 and -4, 1 and 5, and 3 and 5. Okay. That's a big one though, so I'm going to skip it. But that'll give me confidence that like I've ultimately solved this problem. Okay. All right. I don't like that approach that I had anymore because I need to do. All right. I'm just going to blow the whole thing out. It's going to work. Because really, I need to get some kind of like combinatorial like mashup of all these things. So I probably want to think of this more as like a tree. Okay, so what if I did it this way? What if I take each number and then find every number that's valid, every pairing number that's valid. So that would mean, oh shit, what if being valid meant that its index was at least like absolute value of 1 away? I'll bet there's something there. Cool. So let's like that would tell you whether or not a number was valid, and then when you jam them all together, you get the right result, the subsets. Okay, let's see if I can get this to work with the easy one. So I want to go through 1 and 3 and 5. So get 1, get 3, get 5. And then for 1, I want to look at 3 and then I want to reject it because the number is too close. and then I want to look at 5 and reject it because the number is far enough away. All right, and then I want to move to 3. Do I need to go backwards on this? Is it legit to only go forwards? I think so. I think it is okay to only go forward, because otherwise it's not different orders of the numbers. That's not important. Yeah, I think it's only going forward. So this one would only look at 5 and then reject it because the number is too close. And then 5 would be, is the last number, so it's skipped. Okay, so that's like the logic that I'm going for this time. For each of those numbers, all right, I'm going to drop down to a for loop. I think it'll help me think through this a little bit more linearly. Array length. This will have me go through each one of these in turn. So I want to look at 3. So that's array at index. That's 3. And then, oh no, sorry, that's 1. So I get 1, and now I want to look at 3. So I need to cycle through all of the rest of the numbers after the one that I'm in. So that's going to be another for loop. Rest of indexes, or let's see, I'll call that nested index, equals index plus 1. That might break at some point. That's okay. Where same condition, and then we increment it. Cool. Oh, no, I don't think that will break. I think it'll fail the condition the first time. The for loop will just never run. Okay. So this is going to give me access to 3 and 5. So like nested index, that's going to be 3. I'm going to accumulate these up here. I'll call this like matches. And then I'm going to return the matches. Okay. Index. Cool. All right, so I have 1 here, that's 3, and so I want to reject it because the number is too close. So I can calculate a distance with something like nested index minus index. And I can say if, oh shoot, I just thought of a case where this isn't going to work. It'll work on this one though, so we can hopefully get a little bit further. So I can say if distance is greater than 1, then matches dot push. Array at index and array at nested index. Cool. I feel like this should make the first one pass. Got an empty array. Or wait, I think I might have done the setup for this wrong. No, that's right. No, this one should have accepted though. Accept it because the number is far enough away. Okay, never mind. It's fine. Okay, so now my absolute favorite fucking thing in the world to do is troubleshoot nested for loops. So let's see what's happening here. Okay, so it logged 0, 1, 1, 1, 2, 1. 0, 1. Okay, so 0, 1, and 2, there's 3 things. So it did make it through each of the outer loops. Ah, this is why. Then that also nested index. Womp womp. I think I just put that through an infinite loop. Probably why that's mad at me. Yep, I crashed that thread. Oh God, I hate naked for loops so much. Let's see if I can kill that. PS aux. Cool. Kill 190.238. There it is. And we're free. Always a solution. Let's see if that works a little bit better. All right. Well, at least it didn't barf at me. And did it pass? It passed. Cool. That's what I thought. Ah, there we go. Okay, so it'll work with that. But it'll only ever do like 2 matches. So like where this will stop working, like I bet it'll also work for let's see. Yeah, anything with this shape, it'll work, but it'll fall apart as soon as like if I do that. That'll give me 1 and 5, and it'll give me 3 and 7, but it won't give, well, I guess that one would work. So 1, 3, 5, 7 should be 1 and 5 and 3 and 7. Oops, didn't work. Okay, first question, are those valid? Maybe. Oh, it also gave me 1 and 7. That is a, the computer was right. Oh, now it's fussy about the order. Okay, about that. Okay, cool. So that'll work, but problem is if I do another one, 1, 5, and 9 is a valid combination, but it's not going to work on this one. So, all right, all the possible valid ones. One 5, 1 7, 1 9. And then 3 7, 3 9. Okay. And then 5 and 9. Cool. So that'll work, except that's not true. So like if I say result is like actually correct result, it starts the same. We have a few like other totally legal values for this. So we should have is 1 5 1 5 7 nope 1 5 9. We should have 1 5 1 5 9. Yeah. And I think that's the only other one that can match in this. But it's a problem because we can't account for it right now. So if I make that the result. All right, I got my failing test. So if before this gets pushed, I need to see if it's possible to make more matches. All right, so I'm thinking about how I could make more matches. So the distance is greater than 1. Oh, you know what? I could move the push to this second loop out here, but just keep doing the building outside of it. So if I make like matches so far, like that. And then I'm only going to push that in. So I'll do like matches.length and matches, no, sorry. Matches so far dot length and then matches so far dot push. Oh, matches. It'd be something like this. So if there were any matches, then push them into your matches thing. So then this becomes matches so far dot push. Well, let's see, how do I want to do that? You know what? I'm going to start by putting array at index. That'll initialize into it. And then if the distance, you know, works, nested index. Does that work? No, why not? Oh, because that's going to be, that's different now. So this would be, why am I being fucking clever about it? If match so far dot length is greater than 1. Okay, I was mad. This might just be an order thing. So one way to test this is, this is called a characterization test. Oh, actually, you know what? Fuck it. Just has like an any order matcher. Just match array any order. Ignores element position. Yeah, but I can't sort it because they're not, because they're arrays of numbers. Fuck, oh well. All right, back to the characterization test. So instead of asserting what the result is, I like intentionally ignore it and just see what I get back. And see if that's what I had in mind. I feel like that's, I'm starting to feel like I'm not looking at the right thing. Oh, I am. 1, 5, 7, 9. Okay, so why did it have 7? Oh, I know why. The issue is that it's always comparing the distance to the original number, not the last number that got added. Jesus. Okay. So to get this distance, I can't just do nested index minus index. It needs to be the last matching index. So that would be something like last matching index. I can initialize that to the index, but if I push something in, last matching index becomes nested index, and that becomes last matching index. Does that work? 1, 5, 9, 3 and 7, 5 and 9. But it didn't give me like 1 and 7 and shit. Damn it. Got like, that's progress though. That got rid of the 1, 5, 7, 9. I wonder if I can take this. Okay, so the ones that I'm missing, one, 5. Shoot, bummer. I was gonna say that if I have 1, 5, and 9, I know that none of those were next to each other, and so I can get 1 and 9 and 5 and 9 out of that. What I'd still be missing is 1 and 7. But I was thinking like I could take all of those matches and I could go, okay, well, this is like my biggest possible matching array, and I can find all the permutations of that array and not have to do all that distance logic because I knew they were all far enough apart. But shoot, that's not going to work with 1 and 7. Cool. Let's see, how else could I do this? So if I like just start the problem over again, that part of the problem, and I was trying to come up with something totally new. Yeah, I still sort of feel like I should start the problem new. I need that tree kind of thing. Like what I'm thinking of is if I had a tree that was like one, 3, 5, 7, 9. I go, okay, so from this 1, 3, 5, 7, 9. Then this one has 3 and 2 and 1 and nothing. Then this becomes 3, 5, 7, 9, 5, 7, 9. This one is 7, 9. And then this one is just 9. So, and then from there, maybe what I do is like keep treeing off of that. So 3's kids are 5, 7, and 9. 5's are 7 and 9. 7's are 9. 9 has nothing. So then 3, 7, 9. So 5's are 7 and 9. And then 7's is 9, nothing. That one's 9. Then over here, just keep going. So that one's 7 and 9, 9. This one is 9. This one's 9. And done, done, done. Okay. So if I looked at that as a tree, then like maybe the way to do this is to find valid combinations for the tree. So knowing what they are ahead of time sure helps. Okay, 1, 5, 1, 5, 9. So like 1 and 5. Fuck. So 1 and 5 is a match. 1 and 5 and 9. So that's something like that. 1 and 7. 1 and 9. Three and 7. Okay, I think I'm starting to see a pattern here. 3 and 7. 3 and 9. And then 5 and 9. Okay, so I think like the thing that I'm seeing is that if you have this like sorted list of these children that you've made, you have no pairing with the first child. You have a pairing at least with every subsequent child. And then for each of those children, look at this 3791 is 37. 37 would be a match too, wouldn't it be? Yeah, it is. Oh, I see. Oh, I see. It's right there. And since that match 3 and 7 doesn't have like more generations of children, there's no possibility for a match. Okay, so I think that's the magic trick. Is you go through each of these numbers. I'll her out. Each number in the array is the same level of a tree. And then there is a match with the number and every child except the first. For any child where there is a match, it would keep looking down through generations. It would be like its grandchildren are all matches. And then that needs to happen recursively. So, because like if there's 9, 20, whatever, like generations in that tree, you're gonna have to keep doing that. Because like 159 is one of them, but also 15911 would be another one. So you need to keep recursing all the way down until you found one. Cool. I feel pretty good about that strategy. We're at time though, so like I'll admit defeat. But if this is happening in the whiteboarding interview, this is exactly what I would do. I was like, well, this is about how far I got. This is where I think the solution is, and hope for mercy. Cool. Ask me some questions about what I just did.
How long would you reasonably expect to have to do something like this in a technical interview kind of?
Like an hour is not, an hour like feels like not very much time for this, but it's not absurd. Especially if like a lot of time they care much less about whether or not you can solve the problem and a lot more about this kind of stuff. And so if you like reframe the point of the technical interview as less solving the problem and more you got to see how I think for an hour, then like they're probably not going to learn a whole lot more about how you think if you have an hour and a half. I would say I could probably get this, assuming that like this strategy kind of works. I'd probably want another half hour, 45 minutes or something. And I'll bet I could probably do that. Similar thing if I'm just at home, like I don't think I would actually do this a whole lot faster if I wasn't narrating my thought process. Just like I don't think I would think any faster. So yeah, at home, I'd probably 2 hours for a problem like this doesn't feel dumb.
Do you think a company would give a problem that took 2 hours in an hour to see how you think?
Oh, Jesus, yes. All the time. All the time. I've done take-home challenges that were like 20-hour fucking things. You can complain about how unfair it is, or you can do it and see if you get the job.
I guess as far as solving the problem goes, the last thing I would say is instead of going at it this way, we were thinking of like, you can make a map, a JavaScript map, so you can have unique values, and then you just discount negative numbers unless like you have a catch for like if all numbers are negative or something like that. So instead of attacking it this way, is there a way like you could think of where you'd take the indexes as like a key and the value and then just sort it that way, so you kind of go like by highest value? Would there be any use case for that?
Yeah, that sounds okay to me. Yeah, if you were doing a bunch of math on the indexes themselves, and so you end up with a collection of valid indexes, and I wouldn't be surprised if there's like a pattern that emerges with those indexes where you go like, I see. I know whether something is a match or not based on this like index pattern. That's totally possible. Oh, here's another thing I'll say. I would not be surprised at all if you got asked to do something like this in front of a bunch of people for an hour. If you like actually, if this was a valid problem that you were actually doing on the job, I don't think anybody would think it was weird if you took 2 days to do it. It's one of the other like very lopsided things.
So I guess my last question on this one is, because kind of what I wanted to see a lot was how you figure out what the pattern is. Is it just going down this road and just seeing like, cool, smaller to bigger, let me try it like from a different angle just over and over again until the pattern emerges? Is that really like one of the best ways to go about it?
Yeah. So this last thing that I did, this is why people use whiteboards and this kind of stuff. Visual pattern recognition, much easier than like semantic pattern recognition. So as soon as I started graphing this out, like, okay, well, in each of these, it's taking everything but the first one. A lot easier to spot that pattern than when you're just staring at a bunch of numbers. And that with these children, like it would then just skip. And also that like, this like makes me feel better about that road I was going down where I'm only looking forward to like higher in the thing, because yeah, that's exactly how that would work. And so that this is really big over here and then it just shrinks, and then 9 is always the last value. Hell, like I could even see, especially for like a performance optimization of a solution for this, that 9, you could probably use it as a sentinel value. That means that like, all right, anytime you see that last thing, you know you're at the end. So you can just continue on to the next one. But like as humans, your visual pattern matching is like pretty fucking unmatched, like in the animal world. So if you can get a problem into a visual domain, that'll help you a lot.
Thank you.
Other questions? Cool. I'm going to send out the survey. And then when we get those in, we'll stand down and feel. Thank you.
Thank you, Kyle.
You're very welcome.
Thanks.
Yeah. And Ahmed.